My name is Rachel, and I'm a science educator at the Exploratorium. I'm here today to talk to you about a subtle shift a teacher and I made to a fourth grade lesson on magnetism. In this case, a subtle shift refers to a small change to a lesson in order to bring it more towards the next generation science standards, or NGSS. For this particular lesson, the teacher and I shifted the lesson to include the cross-cutting concept of cause and effect relationships. This is an example of a subtle shift in response to how a lesson went. The shift was to add a mini lesson on the cross-cutting concept of cause and effect relationships and to apply this thinking to helping students analyze data. This particular lesson actually had two shifts. In this video, I'm going to focus on the cross-cutting concept shift, but the shifted lesson also included the science practice of modeling, which I'll discuss in a separate video. I'll explain the original lesson in a little bit more detail in a moment. I just want to set the context for this shift, which was that the students were having trouble with the making meaning part of the lesson. They could not analyze and interpret this graph, which is showing that the greater the distance between two magnets, the weaker the force between them. This is an example of a kind of shift that was made in response to the lesson. It was not pre-planned as part of the original lesson. We thought that using the cross-cutting concept of cause and effect relationships might help the students make sense of their data. Prior to this lesson, students had explored magnets, seen that they attract and repel, and seen them interact with other materials. They saw that there is a push or a pull to the magnet. This lesson is supposed to help them see that there is a strength to that push or pull that gets weaker with distance. The setup for this lesson included an equal arm balance with cups on either side, and on one side there was a magnet on a post, the equal arm balance, and then inside the cup, above the magnet on the post, was another magnet that was attracting the magnet on a post. Students put washers in the cup on the other side until the force broke or the two magnets separated them. For the second trial, a spacer was placed in between the two magnets in order to separate them, and with each subsequent trial, another spacer was added. The students needed to record the number of washers for each trial to see if more or less force was needed in order to break the force or separate the magnets. In this lesson, each group of students gets a set of 6 sticky dots in a different color. They're supposed to plot their data on a class chart with their sticky dots so that the teacher can discuss the data with the class as a whole. The lesson was completed exactly as written originally up until this point. The original lesson has a short discussion, maybe 5 minutes, where the students are supposed to see that the farther apart the magnets are, the weaker the force between them. The teacher, however, found that the students were confused by the data, and only 1 or 2 seemed to get that there was a relationship. We told the students that one way we can make sense of the things that we observe is to think about what caused those things to happen, and that we call that a cause and effect relationship, particularly when an action causes something else to happen. For example, if I kick a ball, it would roll down a field. I then introduced the sentence frame blank, so blank as a way to express this relationship. I started with an example they would be familiar with and said, I kicked the ball so, and the kids answered in choral response with the effect. I then went over to the light switch and said, I turned off the lights so, and the kids said in choral response, it got dark. After this mini lesson, we started the science talk, where we asked the students to think about cause and effect relationships in terms of what they observed or what they did in the breaking the force activity. It worked well to use a T-chart here to record the response relationships. Sometimes the students would start with what happened or what they observed, and I would then prompt them to say what they had done before they observed that effect. Also, students brought in evidence from prior lessons, such as magnets connecting when they are close and a magnet falling down to the ground when it was far away from the top magnet. Logistically, it worked well to use different colors for each cause and effect relationship so that the kids could easily track each cause and effect connection. We discovered during this talk that because the relationship was not linear, the students found it confusing. They saw a big effect at the beginning of their experiment. There were 5 or 4 washers difference between each banana chip separating the 2 magnets. But that effect tapered off after the magnets were a certain distance apart, when only 1 less washer or even no less washers were needed to break the force. However, when we referred back to this cause and effect chart, there was consensus that there still was a relationship, even if it was strongest when the magnets were closest and tapered off as the magnets became further apart. Whenever there's a variable that has a direct effect on a system, it can be a productive place to bring in this cause and effect relationship. I've found that you can prompt the kids to see if they can use that word so in their writing or speaking. And if the kids don't seem to be getting it, you can always use a T-chart together to help them see the relationship. What I found from trying out this subtle shift was that using the cross-cutting concept of cause and effect relationships is a really useful tool for the science and engineering practice of analyzing data. Once you've introduced this mini lesson, you can refer back to the so sentence scaffold and the T-chart to cue kids into this kind of thinking, and that just reinforces their ability to use this tool. While the students responded very well to the cause and effect relationship mini lesson in this particular lesson, it's not the end of the story. The students raised other questions that the teacher and I addressed by including a subtle shift to include the science and engineering practice of modeling. And I'll discuss that shift in a separate video.